Good evening, guys, and welcome to your first video homework assignment. Again, I'm glad you've navigated the website so that you've gotten to the video to see that our objective tonight that we're going to cover is objective 317. Students will be able to write a function rule to represent a table of values. This is the objective for tomorrow. So what we're doing is we're going to be writing the notes in our notebook like we talked about in the previous video, and if you're unsure what that looks like, go ahead and open up that video and refresh yourself on how you're going to be taking your notebooks on just that left-hand side tonight. So you're going to be taking the notes for tomorrow's class tonight, and this is kind of like a practice round for what we'll be doing for the next unit. So at any time, feel free to pause the video. If I go too quickly, you always have the power to pause the video and take a little bit more time, or rewind the video if you're unsure of what we do or how I say something, because now you have the ability to manipulate the video around to do what you need to. So if you need more time to write down the objective and head your notebook, go ahead and pause the video. I'm going to just keep on going so that I can be mindful of your time and get you through this homework assignment as quickly and purposefully as possible. So if we look at example 1, go ahead and write down example 1. So what you're writing in your notebook is example 1, write a function rule, and then you're going to copy the table in your notebook as well. So when I look at your notes and I look at your homework for tomorrow, what I'll be looking at is to make sure that you've written all these things down in your notebook. Go ahead and write those down. And if you need more time, feel free to pause the video. So what I'm looking for is a function rule. And a function rule is another way to say, so function rule is actually equal to saying I'm looking for the equation of what linear function is represented in this table. So the way that we represent linear functions, we know, is using slope-intercept form, which is y is equal to mx plus b. And you're writing whatever I write in the red pen and tell you to write that's given here in your notebook. So these are your notes today. So we know that y is equal to mx plus b is a way to write the rule of a function, and that's just slope-intercept form. If I think about what information I can get from this table, I think to myself, and I'm thinking the first thing I want to find is the slope. And so we know that the slope is equal to the change in y, so the change in those y's over the changes in the x's. And then I look over here at this table, and I'm going to switch my color here, and I see that the change, or the difference from this y to get to this y, is a positive 2. So actually what I'm saying is it goes up 2 units. And so the change in y that I see in this first case is a positive 2 over the change in x, and to go from this x to this x, it goes up 1 unit, so this is a positive 1. So here I have the change in y, and here I have the change in x. Now this means that if there's a constant rate of change, that for each additional interval that's the same, that the slope, or the change in y, should be proportional to the change in x. So if this goes up by 2, and this next interval, to go from 5 to 7, also goes up by 2, that means I should be able to accurately predict, this is the constant rate of change, that the change in x over here should be 1, a positive 1, and it is. And so I look over here, now the interval goes from 7 to 9, so it goes up 2 again, which means if there's a constant rate of change, this should go up by 1. Right. So the change in y's, or the difference in the y's to get from one to the other, goes up 2 each time, and the change in x goes up 1 each time. So a simplified version of the slope is just 2. 2 over 1 is simplified to 2. So in my equation then, I know, now working through what I've already found, y is equal to 2x plus b. So y is equal to 2x plus b. Alright, I found the slope, which is the one thing I need to find. I'm trying to find the y-intercept. And if you think back to an objective from a couple days ago, I'm thinking, what information do I have now? I have the slope, which we found is equal to 2. And each one of these points is an ordered pair. So this x value corresponds with this y value in an ordered pair. So I could write the fact I have a point here, and I'm actually going to pick just the 1, 5. So if I have the point 1, 5, that means I have an x value and a y value. So when I go ahead and I rewrite slope-intercept form, y equals mx plus b, I have a value to substitute in for m, right here, which is 2. I have a value to substitute in for x, which is the 1, and I have a value to substitute in for the y, which would be the 5. So when I substitute those values in, this is 2, and solve, this is 5 is equal to 2 plus b. So I have 5 minus 2. So subtract 2 from both sides. And I see b is equal to 3. So if I have found that the slope is 2 and that the b is 3, then I can rewrite the slope-intercept form of the equation as y is equal to 2x plus 3. Y is equal to 2x plus 3. And this is the slope-intercept form of the equation. I can also rewrite this. I'm going to use just one color. Let me use black. I can also write this in function notation, which is f of x is equal to 2x plus 3. And you notice the only thing that changed here was the y came out, and I substitute with the f of x, which is just function notation. Since we're looking for the function rule, you can see either one of these written accurately. First one's just in slope-intercept form. The second one's in function notation. So if I look back at the graph here, rather, not the graph, but the table, I look and I see that actually, if I look really carefully, I don't have to substitute in a point and the slope. I actually can tell from this table what the y-intercept is. How do I do that? If I think about what all of the points on the y-axis are, the x value is always equal to 0, and the y-coordinate gives me the y-intercept. So we said that our y-intercept was 3 down here, and here I see that this point crosses the x-axis at 0. Any point that crosses the x-axis at 0 is also crossing the y-axis. Sorry, any point that has an x value of 0 is crossing the y-axis at the point 3. So right here, when I have the 0 in the x column, the corresponding number in the y column is going to be, not by coincidence, but mathematically, as we've shown through this work in green, it is the y-intercept. Okay? If we're unsure what that means in the table, we can always go ahead and substitute in one point with the slope and solve down like we did with the work that's in green. Now let's take a look at example 2. In your notebook, you're writing down example 2, and you're also writing down the table. If you need more time to do that, go ahead and pause the video. Again, you'll see the steps that I used to solve this. Go back to knowing y equals mx plus b, the slope-intercept form of the equation. I then go ahead and I look for the slope. I need to calculate the slope, which is the change in y's over the change in x's. One more time, anything that I write on this page is something that needs to go in your notebook. So I look over here, this column is going to be my change in y's, this is going to be my change in x's. To go from 14 to 6, I go down 8 units. To go from -2 to 0, I'm actually going up 2 units. So if this has a constant rate of change, I should be able to say that the change in y's over the change in x's, or -8 over 2, which is equal to -4, should be the constant rate of change. So I think right now that the slope is equal to -4. I'm just going to test this theory a little bit. And I see down here that to go from 6 to negative 10, actually that's negative 16. I went down 16 units to go from 6 units to negative 10 units. So I'm a little alarmed right now, like, oh wait, this is a negative 8 and this is a negative 16. But if I come over here and I look at my change in x's, I see that my x, to go from 1, or to go from 0 to 4, I've actually gone up 4 units. So if the change in y over the change in x, again, my change in y over the change in x is negative 16 over 4, then I find that this again simplifies to negative 4, reinforcing that even though these differences in y's are different, the ratio of the difference of y over the difference of x is still the same. In this case, it's still negative 4, which means that when I think about what I need to find next, I know that my slope is negative 4. To test this theory just a little bit further, I could just say to go from negative 4 or negative 10 to negative 14, I'm going down 4 more units. And if the ratio is negative 4 of change in y over change in x, then this should go up 1 unit. And in fact, to go from 4 to 5, I go up 1 unit, meaning it's negative 4 over 1, which is equal to negative 4. So this is right. So my constant rate of change here, even though these values change, the difference between these values change, it's negative 8, negative 16, negative 4, the difference in the change of x changes as well, but the ratio of them stays the same. So here I know that the slope is negative 4. I've got y is equal to negative 4x plus b. The next thing I need to do is find out what this b is. And I could go ahead and substitute in a point. I mean, the easiest point I see here is 0, 6, but if I look really closely at the point 0, 6, and I think back to what I saw in example 1, if the x value is 0 here, that means that graphically this point is somewhere on the y-axis. Actually, specifically, it's at the point 6 on the y-axis. So if I see the 0 here in the x column, I know that the y-axis should be 6. So I'm going to hypothesize, actually, that this, positive b, is going to be, and that's a positive b up there in red, should be a plus 6, based on the observation I made in example 1. So when I go ahead and I write out this entire equation, y is equal to negative 4x plus 6. But I want to just prove this, since this is the second example we've done. So I'm going to come back. I'm going to take this away for a second. I'm going to come back and I'm going to say that, again in green, that if I have a slope that is negative 4 that we've determined, and I have a point, and I'm not going to use 0, 6 just because I'm using that as like my hypothesis right now. I'm going to go ahead and use this first. I'm going to use negative 2 and 14. So I've got a point here that's negative 2, 14, where the negative 2 is my x, the 14 is my y. I'm going to go ahead and substitute these values into the slope-intercept form of the equation. So I'm going to have 14 should be equal to, if I'm right about everything, negative 4 times negative 2, pulling those values from above, plus b. So b, I think, should be equal to 6. Let's find out. So I got 14 is equal to negative 4 times negative 2 is a positive 8, plus b. Subtract 8 from both sides. And is this coincidental? No. That b is equal to 6. 6 is equal to b. So I've proven that that is the case. And again, the last way that I can write this, I'm going to turn back to the black pen, is I can take out that y, can change this from being in slope-intercept form as it currently is up here to being in function notation, which is just f of x, taking out the y, and I'm putting in that y as a function of x is equal to negative 4x plus 6. And here is here are two forms of my answer. the last example we have to go over is example 3. And here, I could give you the story problem that what I see in this table are miles ran and calories burned. So when I've run 2 miles, I have burned 750 calories. When I have run 3 miles, I've burned 825 calories, and so on. So what I want to do, again, is I start with the same thing. If I'm looking to write the function rule, I want to make sure that function rule is in slope-intercept form or in later steps in function notation. So y is equal to mx plus b. First thing I want to do is I want to be able to determine my slope. I'm actually going to come over here and do slope over here since the table's horizontal instead of vertical. Slope again is my change in y's over my change in x's. So to get from 2 to 3, I'm going to go up 1. But if this is a horizontal table, is this my independent variable or my dependent variable? Is it my x or is it my y? I'm giving you just a second to think about this because I want you to think about it before I give you the answer. And in the top one, thinking about which variable determines or is dependent upon the other one, I know that the calories burned are dependent upon the miles that I run. So this is my miles is my independent variable or my x variable, and the calories that I burn are dependent upon the miles that I run. So this is my dependent variable. So here I'm finding that for each change in the x, so I found the denominator first, the calories I burn go up by 75. And I'm just going to test with this blue pen really quickly to see if this is a constant rate of change. So if I go up another 1 here, I should expect, if it's a constant rate of change, that to go from 825 to 900 is 75, and I do. And one more, to go from 4 to 5, again, is a positive 1. So if this is a proportional relationship, then to go from 900 to 975 should go by 75, and that's correct. So my slope, 75 over 1, positive 75 over positive 1 is 75. I'm going to rewrite this equation with the slope that I just found. Y is equal to 75x plus b. Now, I'm looking for the shortcut that I found in the last 2 tables where I had the independent variable was equal to 0 and the dependent variable is equal to something. But if I look at the table, I don't have that. I don't have the independent variable equaling 0. It only goes down to 2. So that means in this example, I have to substitute in the slope and the point. So if my slope is equal to 75 and I have a point, I'm just going to pick the one that looks the easiest, or one that looks easy. It could be 4,900 or 2 and 750. I'm going to go 4 and 900. Where this is my x variable and this is my y variable. I'm going to substitute those values in. Here's 900 equals the slope is 75, the x variable is 4, and it says plus b. So 900 is equal to 75 times 4, 75 times 2 is 150, 150 times 2 is 300. Subtract 300 from both sides. So b should be equal to 600. That means that when I rewrite this equation, I will be writing it as y is equal to 75x plus 600. Or f of x is equal to 75x plus 600. But this was a story problem. I had some labels with these. I was talking about the calories I would burn for the miles that I ran. So what we want to do is we want to be able to interpret the slope and the y-intercept before we move on to our practice. So in this example, the slope was 75. If I go back up to the relationship between the independent and the dependent variables, it's the miles for each additional mile. I am burning 75 more calories. So the number of calories I burn increase for each additional mile that I'm running. So I'm going to interpret that down here below. So we're going to write this in our notebooks. And the slope means that for each additional mile I run, I burn 75 calories. And the y-intercept then is 600. And if I were to think about the ordered pair for the y-intercept, it would be, like we saw in the table, 0, 600. And if x is representing the number of miles I've run, this means I've run 0 miles. I've already burnt 600 calories. So the interpretation of the y-intercept is when I've run 0 miles, or you could say before I started running, either way, before I started running or when I've run 0 miles, I've already burned 600 calories. And this might be due to the fact that you walked to where you're going to run, or let's say you did some push-ups before you started running, or whatever. For whatever reason, you'd already burned 600 calories before you started running. So, once again, these are the notes that need to be in your notebook for tomorrow. When you get into class tomorrow, I'll check your notebooks to make sure all of the notes are there. And we will test you with an entrance ticket and get you sorted so that some of you can work on projects. Some of you will be with me for a portion of the period reviewing some of these examples. But I hope you guys were able to find the video okay, and I hope it was instructive. And once you have this done, you have completed your homework assignment for the night, and I will see you guys in the morning. Have a good night.